Hello dear students, welcome back to my online math class. I am Teacher Ray, your teacher for today. Before we start, I want you to have your math textbook, your copybook, and pen. Before moving on to our lesson today, let's have first your answers for your homework of the previous lesson. Lesson 7.3, Understand Experimental Probability. Let's start with practice in problem solving in your textbook, page 371. Number 8. Liza flips a coin 50 times. The coin lands heads up 20 times and tails up 30 times. Complete each statement. The theoretical probability of the coin landing heads up is 50%. Based on Liza's result, the experimental probability of the coin landing heads up is 40%. So, the theoretical probability is greater than the experimental probability in this experiment. Number 10. The table shows the results of a survey of 100 people randomly selected at an airport. Find the experimental probability that the person is going to CTE. Looking at the table, CTE has 8 number of responses, and the total number of responses is 100. So the probability is 8 out of 100 or 8%. Number 13. Assessment practice. In a survey, 125 people were asked to choose one card out of 5 cards labeled 1 to 5. The results are shown in the table. Compare the theoretical probability and experimental probability of choosing a card with the number 1. The theoretical probability is 1/5 or 20%. The experimental probability is 15 out of 125, or this is equal to 12%. So the theoretical probability is greater than the experimental probability. Today I am going to discuss Lesson 7.5, Determine Outcomes of Compound Events. This is in your textbook, pages 385 to 390. And here is the objective of the lesson. Use a tree diagram, a table, or an organized list to represent the sample space for a compound event.
How can you represent all the possible outcomes or sample space of a compound event? Think about this question during the lesson. Haley has 2 sisters and no brothers. Josh has 2 brothers and no sisters. They wonder what the chances are, in a family with 3 children, that the children will be all boys or all girls. How can they determine all possible combinations of boys and girls in a family with 3 children? The first step is to list the different events. How many events describe a family with 3 children?
Select your answer.
The three events are the births of the three children. Each child is either a boy or a girl. This is an example of a compound event. A compound event consists of two or more events. This compound event consists of three events. Our next step is to make a tree diagram to represent the sample space. The diagram begins with child 1, who is either a boy or a girl. That's two outcomes so far. For each outcome for child 1, there are two outcomes, boy or girl, for child 2. And for each outcome for child 2, there are two outcomes for child 3. The tree diagram shows all the possible outcomes of the compound event. For example, we can follow the branches on the left side of the diagram, which shows the outcome of a boy, then another boy, then a third boy. Label this outcome BBB.
Select each footprint in the bottom row to see an outcome in the sample space.
So it's BBB. If we choose this, it's BBG. It will give a result BGB. The outcome is BGG. Then it's GBB. It's GBG. It's GGB. And the last one is GGG.
Haley and Josh can make a tree diagram to show the sample space of boys and girls in a family with 3 children. The sample space has 8 equally likely outcomes. The chances that a family with 3 children has all boys or all girls is 2 out of 8, or 1/4. That's more likely than I thought. Now you know how to represent the possible outcomes of a compound event.
Jorge will flip 2 quarters at the same time. Complete the tree diagram and then list the sample space of this compound event. Use H for heads and T for tails.
Let's of quarter 1H. It has branches H and T. For T, it has branches of H and T. So the sample space is HH, HT, TH, and TT.
A game is played by spinning the 2 spinners shown. Players match the results of the spinners to combinations on their game cards. How many different combinations are possible?
We will use a table to represent the sample space. Remember, the sample space shows all the possible outcomes. The table is 6 by 6. There are 6 letters and 6 numbers. So we have A1, A2, A3, A4, A5, A6, B1, B2, B3, B4, B5, B6, C1, C2, C3, C4, C5, C6, D1, D2, D3, D4, D5, D6, E1, E2, E3, E4, E5, E6. We have F1, F2, F3, F4, F5, F6. So there are 36 different letter number combinations. So the sample space consists of 36 possible outcomes.
Stan will roll a number cube labeled 1 to 6 and flip a coin. What are all the possible outcomes?
So in this example, we will use an organized list to represent the sample space. We have 1H, 1T, 2H, 2T, 3H, 3T, 4H, 4T, 5H, 5T, 6H, and 6T. For each of the 6 possible outcomes of the number cube, there are 2 possible outcomes for the coin. So there are 12 different combinations, and the sample space consists of 12 possible outcomes.
The bag contains tiles labeled with the letters A, B, and C. The box contains tiles labeled with the numbers 1, 2, and 3, and one number tile. Represent the sample space using either a table or an organized list.
By using an organized list, we have A1, A2, A3, B1, B2, B3, C1, C2, and C3. And now we're done with the first part of our lesson. Hope you understood the lesson very well. See you in the second part.